Alright, so welcome back everybody. So the goal of this video is to introduce this idea of cross-validation. And so cross-validation is going to let us assess how our model performs on some data that weren't used to fit the model originally. And so that's really the important idea of this cross-validation, is that we're eventually going to test the model on some data that were used, or on some data that wasn't used in the original model fit. An analogy you could think about would be like, okay, if you were to take a practice exam, then it wouldn't really be a fair test for you to just take that practice exam again to test how much that you learned. It's not really fair because you've already seen the practice exam to begin with. What would be a fairer test is to take an exam that you hadn't seen before. Similarly, when we use, if we fit our model to some set of data, then we don't really want to use that same data to assess how the model is doing. Instead, we want to test the model on a different set of data that the model hasn't really yet seen before. And so to talk about this more, we're going to define a couple things. So we're going to define a training sample, which we're just going to define as a subset of the data used to train the data to find the best model. So if you have like an entire data set, sometimes this would maybe be close to like 80% of your data. A holdout sample is a subset of the data that's just used to test the model that was fit with the training sample. And so typically this is a smaller subset of your data, maybe the remaining 20%. So you're splitting your data into a training sample and a holdout sample. I will point out that this is like the easiest type of cross-validation there is. If you were doing this in practice, you would probably do something a little more complicated, some form of k-fold cross-validation would be like the next step up. But we're not going to talk about that just for time. We're just going to talk about splitting our data into this training and holdout sample. And so we're going to outline kind of how this cross-validation procedure would go, and then make a few notes that our outline really isn't as simple as it originally appears to be. And so you might start by, we've talked about model selection and best subsets. You might start by using best subsets to find the best possible model under some criterion using just your training sample. So we've talked about some criterion like adjusted R-squared, MALOCP, AIC, or BIC. You would use the training sample and best subsets to find this best possible model. Then we might test this model on our holdout sample. And what we're going to do is we're going to use the model to obtain some predicted values for our holdout sample. Once we have those predicted values, we're going to find, like you could almost think about them as like residuals. So the observed minus the predicted based on our model for the holdout sample. So a good model is going to have these residuals be as small as possible, because if they're small, then that means that the observed response in the holdout sample is going to be close to the fitted response in the holdout sample. And so we want that to be true for as many observations as possible. And so that really leads into this step 3. We're going to investigate the quality of the predictions just by looking at a few things for the holdout residuals. What we're going to look at will be discussed in the next video. For now, we're going to kind of leave it at that. But these 3 steps kind of present it in a more simplistic way. There are other things to kind of think about, though. Like maybe in one of these steps, do you want to investigate higher order terms or interactions? So the best subsets didn't really consider that, but the best model for prediction could have like an x squared term, an x cubed term, could have a couple of interactions. So at some point, those probably need to be investigated. At some point, we also need to think about checking model assumptions. And this includes checking things like outliers or influence. If a point is influential, do you want to keep it in your training sample? Do you want to get rid of it? It's hard to know exactly whether that influential point is going to be beneficial to prediction or detrimental. And so these are other things that we kind of have to think about. And so finally, just kind of reiterating what we had talked about before, is this point that the holdout sample has never seen the model and so because it's never seen this model, we're thinking that kind of what we're going to look at in the next video, the quality of these predictions, it's going to be a more fair assessment. Just because this holdout sample wasn't used to fit the model, and so it hasn't really seen the model hasn't seen this holdout sample data before. Okay, and so you'll kind of see how to divide a data set into a training sample and a test, or in a holdout sample in the R portion of this. Again, working with the body fat data, and we'll also see this idea of outliers and influence come back in the body fat data as well. And so there will be a point or two that we'll kind of see throw everything off. And so that'll be interesting to look at in the RStudio portion. Okay, and so until next time, have a good morning, afternoon, or evening.